Assalamualaikum warahmatullahi wabarakatuh. Okay, so today we're going to start our lecture with chapter 1, Introduction and Measurement. Okay, so learning outcome by the end of the class, you should able to identify the difference between qualitative and quantitative observation, and then you able to list the 7 standard SI units, okay, and the symbols, and explain. Give several examples derived by SI units and predict or apply some prefix needed if you want to change the size of the units, and also to determine the number of significant figures, alright, and use the correct conversion factor in calculation. So we start with the introduction. What is chemistry? Chemistry is study of 3 things. So we study on matter, we study on changes of the matter, and also we study on energy that makes the changes, right? So first, we talk about matter, we talk about its properties. What are the properties of the matter itself? And then how does the changes of the matter undergoes, right? Is it involve any reaction or not? Okay, and then how much energy has been released or energy needed to make the changes. So those are the 3 things that we need during the during the study, alright? Okay, and then next, what is matter? So matter is anything that has mass and occupies space. Okay, it's everything that around you. So the material of the universe, matter can exist in 3 states, such as in solid, liquid, and also gas. Right. Dreams, thoughts, heat, are they kind of matter? Because we said that our matter exists in 3 states, solid, liquid, and gases. These 3 things like dreams, your thoughts, and also heat are considered as matter. Alright, so you have to think about that. Alright, and then when we talk about matter, we must know what are atoms and molecules. So atom is the smallest distinctive units in the sample of the matter, while molecule has larger unit of 2 or more atoms. Okay, so and then you need to know the physical and chemical changes. Just now we talk about matter, and then we need to know the changes. Does it involve any physical or chemical changes? These are the properties of the matter. Alright, so physical changes means that there are concerns on energy and state of matter. It do not produce a new substance. For example, physical changes, it's just the same substance before and after. There's no changes of the substance after the reaction. Right, so it involves changes in state or phase, such as melting, freezing, vaporization, condensation, or sublimation. For example, it's including crushing a can. Once you crushing a can still a can. Okay, melting an ice cube is still water. Okay, it's still H2O. And then breaking a bottle, though the physical state doesn't changes, alright, but we can consider that it's still a type of glass. Okay, right. But chemical changes, it takes place on the molecular level. This one is going to produce a new substance. Okay, it's different from beginning. Okay, before and after they are produced different substance. Okay, for example, A react with B to produce C. Okay, it's considered different things. For example, combustion or burning, you burn something, a substance, alright, so it produces something else. Or you cooking an egg, okay, from egg yolk, for example, right, it turned into the solid egg. Okay, rusting an iron pan. Okay, before iron pan turned into rust, is considered as a good and new brand of the pan. And then while it being used for a long time, and then it's exposed to the air, rusting happened. Okay, so before and after consider different thing. And then you're missing hydrochloric acid, for example, with sodium hydroxide to make salt and water. So the end product, salt and water both are totally different things. Okay, so that is involved chemical changes. Okay, matter can be classified, as I said just now, matter can be classified into 3 things: solid, liquid, and gas. Alright, so that also can be differentiated into 2 things. Is it matter is considered in mixture or pure substance? Okay, so it's involved physical method here. Alright, if you mix something towards it, towards solid, for example, from liquid, you mix something into the solid, for example, on the left figure here. Okay, you can see this is process of mixing. So once you mix the metal, solid and liquid together, so what will happen? Is it become mixture or is it become pure substance? Right. Or from something that been mixing around, okay, on the right figure, something that has mixings around, and then you want to spread them, okay, you want to split them into their own substance. For example, we do process of separating by using the separating funnel. Okay, so here you can see that from solid and residue remains in the filter paper, somehow filtrate will be come off. So this is process of separating. So two things, either it become mixture or it's become pure substance. So this is on the right one, this is a pure substance. Right, so mixture, we can consider mixture into two things. Alright, okay, either homogeneous mixture or heterogeneous mixture. This is all of you already know. So homogeneous mixture means that it has one phase, alright, in a solution, but heterogeneous solution, it has different phase. Okay, for example, precipitate. Alright, so it's also, just now we see that classification of matter consists of pure substance or mixture just now. So in a pure substance, the chemical methods involve compound or elements. Okay, if it involves combustion, it's going to produce compound. If it involves electrolysis, it's going to produce elements. Okay, for example, pure substance, it can produce like compound. You do refrigeration just now, and in the end your end product, for example, is water. So that's a classification of compound. But if you do the separation just now, you find an element. Okay, you produce another element, you split hydrogen and oxygen differently. Right, so that's this process of electrolysis, for example. So that's produce the element. Okay, it's produce a single thing, while compound is produce a combination things. Okay, right. So in scientific methods, we know that scientific methods start with observation, and then we come up with hypothesis, and then we do the experiment. Okay, we come up with hypothesis first, because of based on our observation. So we see our observation first, and then we come out with hypothesis, then only we do the experiment. We didn't do the experiment without the hypothesis. So we know already what we want to do based on the hypothesis, our prediction, based on our observation. Then only we carry out the experiment. Okay, from that experiment, we come out with theory. Okay, so this theory has to be tested for further experiment, or then the theory has to be modified. Okay. Okay, so next thing, observation. Observation is normally fundamental in science. We just witness and then we record the behavior, and then it can be qualitative or quantitative. This is by our naked eyes. So qualitative measurement means it does not involve number, just quality measurement. You observe and you say it's good or not. So that is qualitative. Alright, so you observe the sky, you see the sky is blue, so you state as the sky is blue, and then you say water is a liquid. That is observation, just qualitative. Alright, study of animal behavior. Is it that animal eat, sleep, run, and so on? So that is the just behavior. So that is some of observation. But quantitative is involve number. Okay, it consists of two parts. Okay, number and a scale. Both number and scale must be present for measurement to be meaningful. For example, water boil. You see water boil by observation, but you see the number. Okay, water boil at 100 degrees, and water density is 1 gram per mil, for example. So this is quantitative measurement. It's much more accurate. Okay, so these are among the different instruments that enable to measure the substance properties. For example, in order to measure length, we can use meter stick or breadth. Okay, and then in order to measure volume, we can use like a burette, pipette, graduated cylinder, volumetric flask. Mass can be measured by balance, okay, either analytical or thought balance, all right, or either loading balance. And then temperature obviously can be measured by thermometer. Okay, so these instruments measure microscopic properties, meaning that they are visible to naked eyes and related to large scale. Right. Then microscopic properties, some things that are really small, okay, where our naked eyes can't see, we can view via microscope, okay. Alright, it can be determined indirectly in terms of size of particle, length of chemical bond. Alright, so in terms of this, scientists recognize that there must be standard system for the units has to be adopted so that all the scientists can use uh, the same and similar system, right? If every scientist has her or his own standard units, there will be complete chaos. All right, so there are two type of system that normally being adapted. One is English systems, okay, for example in US they use gallon, pound and feet, but somehow there is another system that they call as metric system where we can normally being used in the most of the rest of the world, like in UK and so on. All right, like liter, kilogram, meter and so on. Okay, so this is the SI units. Okay, for physical quantity we have length, mass, time, temperature and so on. This is the name of the units. Length in meter, unit symbol if m. So mass, kilogram, unit symbol if kg. Time normally in seconds, so s. Temperature in Kelvin for K, and then the rest. Okay,